Hello friends, myself Ketan M. Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. My subject is Switch Gear and Protection, 4th year, 7th semester, and topic is Electromagnetic Relay. In Switch Gear Protection, chapter number 1, the introduction of protective relaying and electromagnetic relay. Syllabus content. In chapter number 1, first introduction to protective relaying and electromagnetic relay. There are number of content. First, construction and working of different electromagnetic relay, fault, causes and effects, protective zones, primary and backup protection, desirable qualities and terms of protective relaying, basic connections of trip circuit, types of relay units, relay pickup, reset or drop out, pickup and drop off ratio. Flow of content, necessity of switch gears, definition of switch gears, electromagnetic relays, hinged armature, attracted type relay, shaded pole induction disc relay, wattmetric type induction disc relay, induction cup relay, moving coil relay and torque production in induction relay. See, what is switch gear and why it is important in power system. Okay, switch gear are necessary at every switching point in the power system because there are several voltage levels and fault levels which has to be controlled and protected by accessible switching devices and for isolation if the need areas. Several voltage levels means there are high voltage levels up to kV levels and fault levels means line to line fault, line to ground fault, etc. Okay. Next, switch gears. Definitions of switch gears. Switch gear is a general term covering all equipment used for switching, protection, control and isolation in power systems. All equipment used for fault clearing is covered by the term switch gear. Switch gears are used in general generations, transmission and distribution systems, whereas control gear are used in consumer circuit. Okay, so switch gear, switch means power system sides the numbers of equipments are used, and gears means protective device is consumer side. It is also used in power system side means generation, transmission and distribution side, but it is also used in consumer side. There are number of classification of in electromagnetic relay. In electromagnetic relay, first attracted armature, induction disc type, induction cup type and moving coil type. In classification of relay, there are number of technology wise and number of functional wise relay in used in power systems. In based on technology, the electromagnetic relay, static relay and microprocessor based relay are used. In electromagnetic relay, there are 4 types of relay is used, and based on that function, the overcurrent relay, under voltage relay, impedance relay, under frequency relay and directional relay is used. First, hinged attracted armature type relay. Hinged attracted armature type relay is a electromagnetic type relay. In the attracted armature hinge type relay is same as balance beam polarized moving relay. The simplest type which respond to AC as well as DC. All these relay have the same principle, that is an electromagnetic force is proportional by the magnetic flux, which in turn is produced by the operating quantity. The electromagnetic force exerted on the moving element is proportional to square of the flux in the air gap. on the square of the current. In DC electromagnetic relay, this force is constant. If this exceeds the restraining force, the relay operates reliably. In AC electromagnetic relay, the electromagnetic force is force proportional to I square. So, force proportional to I square means K is a constant. So, Fe equal to Ki square. Here, hinge armature type relay, the coil is wound on the core and armature is connect with this coil circuit and this connected to tip circuit. So whenever the flux produced in the armature, then current I is flow into the coil and flux will produce. Then armature get to attract with this portion and tip circuit will close and isolate to faulty section and healthy section. Okay. Second, shaded pole induction disc relay. Shaded pole induction disc relay is a type of induction type relay. Okay. In general arrangement, the shaded pole structure is shown in figure. We saw the shaded pole induction disc relay. It consists of pivoted aluminum disc free to rotate in the air gap of an electromagnetic. Here it is a disc. A disc in between shaded pole disc is rotate. Okay. One half of each pole of magnet is surrounded by a copper band known as shading ring. Okay, this is a shading ring. The alternating flux phi s in the shaded portion of the poles will, owing to the reaction of the current induced in the ring, lag behind the flux phi in the unshaded portion by an angle alpha. Okay. So flux will produce to shaded to unshaded ring. Okay. These two AC fluxes differing in phase will produce the necessary torque to rotate the disc. So after flux is produced, the driving torque T is produced. So T proportional to phi s into phi u into sin alpha. Phi s means shaded flux and phi u means unshaded flux. So T proportional to phi s into phi u into sin alpha. And assuming the flux phi s and phi u to be proportional to current I in the relay coil. So torque proportional to I square sin alpha. This shows that the driving torque is proportional to square of the current in the relay coil. Okay. So shaded pole induction disc relay is a robust and reliable constructions. Fluxes displaced in space and time, eddy current in disc rotation, a driving torque, brake magnet to avoid overrun, used for overcurrent protection, used for slow speed relays. Okay. So shaded pole induction relay is a induction type relay. Next, watt metric type induction disc relay. It is also types of induction type relay. In watt metric type relay, there are two electromagnetic are used, upper and lower. Upper and lower magnet produce two different fluxes, phi 1 and phi 2. Then energized by two different sources, and if energized by same source, then R and X would be made different to get phase difference between fluxes. Okay. It consists also of pivoted aluminum disc arranged to rotate freely between pole of two magnets. Upper electromagnet carries two windings, primary and secondary. Primary winding carries the relay current I1, while the secondary winding is connected to winding of the lower magnet. The primary current induced EMF in the secondary winding and so circulates a current I2 in it. The Flux phi 2 induced in the lower magnet by the current in the secondary winding of the upper magnet will lag behind phi 1 by an angle alpha. So the two fluxes phi 1 and phi 2 differing in phase by alpha will produce a driving torque and the disk proportional to torque proportional to phi 1 into phi 2 into sin alpha. Okay. So if this circuit is open, no flux can be set by the two lower magnet. Okay. Therefore, the relay can be made inoperative by opening and secondary winding circuit. Okay. Next, induction cup relay. Induction cup relay is also a induction principles. It most closely resembles of an induction motor, except that the rotor iron is stationary, only the rotor conduction portion being forced to rotate. The moving element is a hollow cylindrical rotor which turns on the axis. The rotating field is produced by two pair of coil wound on 4-pole as shown in figure. Here in 4-pole induction cup relay, okay, the stationary core inside rotating cup, spindle carries arm, closed relay contacts, spring for restraining torque, no brake magnets. Okay, principle of induction motor. Rotor is a cylindrical inverted cup. Two pair of coil produce rotating field. Cup has less inertia than disc, less magnetic leakage. Torque per VA is the 3 times than disc type. Operating time is minimum 0.01 second and its high torque and inertia ratio and for suitable for higher speeds. Okay. The rotating field is produced by two pair of coil wound on 4-pole as shown in figure. The rotating field reduce currents in the cup of the provide the necessary driving torque. If phi 1 and phi 2 represent the fluxes produced by the respective pair of poles, the torque produced is proportional to phi 1 into phi 2 into sin alpha, where alpha is the phase difference between two flux. The control spring and back stop for closing of the contacts carried on an arm are attached to the spindle of the cup to prevent the continuous rotation. In induction cup relay, structures are more efficient torque produced than either the shaded pole or the watt-hour meter structure. Therefore, this type of relay has very high speed and may have an operating time less than 0.01 second. Next, moving coil relay. Moving coil relay is a same as the here rotating moving coil relay and axial moving coil relay. Here the coil is connected with the moving contact and other is a fixed contact and this is a permanent magnet. Okay. When permanent magnet is attracted to the moving contact, okay, then both contact are closed, fixed contact and moving contact, then relay will actuated means operated with this and the section faulty section will remove the healthy section, same as axial moving coil relay, same. Next, torque equations. Theory of induction relay torque. Okay, here it is F1 and F2 force will each other attract and phi 1 and phi 2 flux produce and I1 and I2 current will produce. In electromagnetic induction disc relay operates on the principle of induction motor and are widely used for protective relaying purpose involving AC quantities. They are not used with the DC quantities owing to the principle of operation. An induction relay essentially consists of a pivoted aluminum disc placed into differing magnetic field. of the same frequency but displayed in same time and spaces. The torque produced in the disc by the interaction of one of the magnetic fields with current induced in disc by other. Here, these alternating fluxes induce EMF, small e1 and small e2 in the discs, which lag their respective fluxes by 90 degree. These EMF lead to the flow of eddy current I1 and I2 by the interaction of phi1 with I2 and phi2 with I1. A driving torque is produced. Okay, the current I1 and I2 lag the voltage E1 and E2. Okay, see the figure by the impedance angle lambda of the disc. So the vector diagram is phi1 proportional to magnitude of I1 into sine omega t and phi2 equal to magnitude of I2 into sine omega t plus alpha. So alpha is a phase difference between phi1 and phi2. Phi1 and phi2 is a instantaneous value of fluxes and phi2 leads phi1 by an angle alpha. So phi1 equal to phi1 into sine omega t, phi2 equal to phi2m sine omega t plus theta, and E1 proportional to d phi1 by dt. Put the value of phi1 m into cos omega t, same as I1 proportional to phi1 m cos omega t, same as E2 proportional to d phi2 by dt. Put the value of phi2, so E2 proportional to phi2m sine omega t plus theta, and I2 equal to proportional to phi2m cos omega t plus theta. Now F1 equal to proportional to phi1 into I2. Put the value of phi1 and I2. So F1 proportional to phi1m into sine omega t into phi2m into cos omega t plus theta, and F1 proportional to phi1m into phi2m and into cos omega t plus theta into sine omega t, same as F2 proportional to phi2 into I1. Okay, see in the figure कि F2 proportional to phi2 and phi1. Well, both direction is, so F2 proportional to phi2m into sine omega t plus theta into phi1m cos omega t. So F2 proportional to phi1m into phi2m into sine omega t plus theta into cos omega t. Now final equation F equal to F2 minus F1 because the force is opposite. So F proportional to phi1m into phi2m in square bracket sine omega t plus theta into cos omega t minus cos omega t plus theta into sine omega t. So final equation F proportional to phi1m into phi2m into sine theta. Okay. So force produced in induction relay F equal to K into phi1 into phi2 into sine theta. Okay, this is the final equations. Now this is a GTU paper questions. In 2018-17, these type of questions are asked into GTU exams. Okay, the working principle of induction relay and also derive an expression for the torque produced by it. Okay, it is 7 marks. Then explain induction disc type electromagnetic relay with the torque equation. It's also 7 marks. And explain comparison between static and electromagnetic relay, and also 7 marks. Okay, so this theory is important for you in exam. Okay.